Hello, my dear students. Welcome to my Java programming course. In this lesson, we are going to learn about Lambda expressions in Java. This video is part of a complete Java course I have published on YouTube. If you are interested in becoming a Java expert, I would highly encourage you to check out the rest of the videos as well. Well, my dear students, if you have followed this course from the beginning, I'm pretty sure you understand what is inheritance in Java. Here I have shown you two different Java classes, the animal class and the dog class. If you look closely into the dog class, it is actually a child class from the animal class. You can see I have used the extends keyword. You can also see that I have actually called a method that is defined in the parent class, in this case the move method. It is possible that all the methods and attributes defined in the parent class will be accessible to the subclasses or the child classes in Java inheritance. You must also remember for your exams, you might be asked that what kind of a relationship the inheritance builds up. It is always a is a relationship. In this case, we can say dog is a animal. The child class can always act as a parent class instance. As always, my dear students, I try to deliver the content in an organized fashion. Therefore, this video I have broken down into three different sections. First, we must talk and understand about what are anonymous classes in Java. Later, we should understand what are functional interfaces. Once we understand these two foundational concepts in Java, understanding about lambda expression is just a breeze. The English word anonymous means there is no specific name. In Java programming language, we can create a class without an exact specific name. We call this kind of classes as anonymous classes in Java. Anonymous classes can only create a single object. And also remember, you cannot create an anonymous class out of thin air. That means it can be either a subclass of an existing Java class or it has to be an interface implementation. There is no other possibility in Java programming language that you can create an anonymous class. So make sure you understand these three restrictions when it comes to anonymous classes. The parent class of this anonymous class that I have written here is the animal class. Also note that at the end of the anonymous class body, you must put the semicolon because this whole anonymous class can be compressed down into a single statement of Java. So if you remember at the first lesson, I taught you that every Java statement must ends with an semicolon. So here, that's why you must provide the semicolon at the end of the anonymous class body. Just like any other Java class, you can create variables, methods as long as you want. And also, since this anonymous class is always a subclass or an interface implementation, you can or you have the possibility to override the parent class methods. For example, in this case, this particular anonymous class I have written here, I have actually overridden the move method. As a summary, you have to remember that anonymous class can either be a subclass of a regular class or an interface implementation. There is no other possibility that you can create an anonymous class in Java. So here I have a regular Java project which has only a single Java class. You can see on the left hand side pane, I have only a class called Lambda Exercise. Now what we are going to explore here in this exercise is how we can create anonymous classes either from extending a regular Java class or implementing an Java interface. Now that we have created two Java objects from anonymous classes that was created with different approaches, I'm going to call these methods through that anonymous objects. Here you can see the outputs are coming from those anonymous objects. The first anonymous object is actually from a extending and Java class, and the second anonymous object I created implementing and Java interface. If you pay attention to the anonymous class structure, they are pretty much identical. For example, if I expand these two anonymous class bodies, this is the anonymous class body for the extending the water class and creating an anonymous class. And this is the anonymous class body for implementing the liquid interface. You can see we have simply provided the abstract method implementation when it comes to interfaces. When it comes to extending a Java class, we have the possibility of overriding the parent class methods. So you can see the structure is similar. We start the anonymous class body after the constructor using the curly brackets. So whatever you write between these curly brackets considered as the class body. Since the Java 1.8 version, we have the functional interface as part of the Java language. Functional interfaces are nothing but simple Java interfaces, but those interfaces can only have a single abstract method. And there is an inbuilt Java annotation that is provided by the language itself. You can decorate an interface using the at functional interface annotation. What do you think about the following example? The my string list is a Java interface and it has three different abstract method definitions. However, I also try to call it as an functional interface. Do you think this will compile? No, because the rule is the functional interfaces can only have a single abstract method. But in this case, we have three abstract method definition, so it will not compile. However, the auto-closable interface does have only a single abstract method. So that means we can safely say this is an functional interface and it will compile without any errors. Good job, my dear students. You came to the most important part of this video about Lambda expressions. Lambda expressions, we can say they are more like anonymous methods. Just like anonymous classes where we didn't have a name for that class, in Lambda expressions, we don't have a name for a method because we are talking about an anonymous method. Lambda expression have only two different main parts. The first part is where we define the method inputs or method parameters. And the second part is where we provide the method body, or you can say method implementation. Here we can see there is a regular Java method or normal Java method that I have transformed into a Lambda expression. When you look at the Lambda expression, you can see we have the exact same method parameters and also exact same method body. However, I try to write the entire Lambda expression in a single line. So I compress the above method body into a single line of Java statement. And you can see at the end of the Lambda expression, you have to provide the semicolon because the entire Lambda expression, it's a single statement in Java. Here is a quick review about what we have learned so far in this video. We learned about functional interfaces. Functional interfaces are the regular Java interfaces where you have a single abstract method. And also you learned about anonymous classes. Anonymous class can also be an implementation for any Java interface. Moving forward, what we are going to look at is how we can transform this anonymous class into a Lambda expression. Lambda expressions are actually meant for functional interfaces. And that is the reason I have actually taught you at the beginning of the lesson the anonymous classes and the functional interface so that you can clearly understand where the Lambda expressions fit into this story. So you have to remember, my dear students, whenever you are writing a Lambda expression, you are actually writing an anonymous class that is implementing a functional interface. Not just any interface, it must be a functional interface. All you need to do is take this particular method and convert it to a Lambda expression. In this case, you have to pay attention to the method parameters and the method body. In this case, the functional interface is truth detector, that is the data type. And I have provided the variable name as crystal ball. And then after the equal sign, I have wrote my lambda expression. In this case, it's a very simple statement. And at the end of the statement, I must provide the semicolon. So now, my dear students, what you are going to learn is how to write lambda expressions. So in order to do that, first we should write a functional interface and then write an anonymous class for that functional interface. Then we can think about transforming that anonymous class into a lambda expression. Let's imagine a story that you are lucky and you are working for a generous company that gives bonus to their employees. So we will take this story and try to understand lambda expressions. So here what we did was we simply created an anonymous class and created an object out of that anonymous class. And then we have simply called the bonus method that we have implemented inside that anonymous class here. Now we are going to write an lambda expression. Before that, I want to pay attention to the company interface. Here, when you look at this interface, what characteristic does it really showcase? You can see it has a single abstract method. So that means we can safely say this is a functional interface. You can even go ahead and mark it with the functional interface annotation. If we look into our company interface again, we have only a single abstract method. You can see this is the method signature. And if you pay attention to this method signature, you can see it accepts a single parameter and it must return a double primitive value. So we have actually implemented this particular interface when we write our anonymous class body. Here you can see we have actually provided the implementation for that abstract method. We can simply copy this logic into our new lambda expression. You know, my dear students, lambda expression have this very special notation, just like an arrow that points to the right hand side. So that goes in between the parameter section and the method body. Just like the anonymous class body here, we had to provide the semicolon. We must provide the semicolon at the end of the method body for the lambda expression as well. So let's go ahead and run the program and make sure our lambda syntax is correct. Sometimes, my dear students, in lambda expressions, some of the syntactical notations can be redundant. For example, in this case, we have a very simple lambda expression. In that case, some of these additional notations can be removed further. First and foremost, mentioning the data type under the parameter section is completely optional. So we can actually take this parameter type and then keep only the variable name or the parameter name. Also remember, when you have only a single method input parameter, you don't have to have the round brackets. When you have a single line of code inside the method body, the curly brackets or curly braces are completely optional. You can get rid of them. However, note that here we have used the return keyword. Return keyword cannot exist without the curly braces. If you are removing the curly braces, you have to take out the return keyword as well. First, let's remove the return keyword and also the semicolon in the same line. Now we can safely remove the curly braces. This is a completely valid lambda expression. Since this is a single statement, I'm going to write it in a single line. You can clearly see why we prefer lambda expressions compared to the anonymous class bodies. Now let's imagine the company doesn't always give 15%. It's a variable factor. Let's go ahead and modify the abstract method definition in our interface. Pay attention, my dear students, when you have more than one input parameter, you must put the round brackets. Now our lambda expression comply to the agreement in the functional interface abstract method. So now whenever we are calling that abstract method, we have to pass the actual parameter values. In this case, we have to pass the second parameter for our bonus method now. One last thing, my dear students, you can always write any lambda expression as an anonymous class. For example, the lambda expression we have wrote here, we can actually rewrite it as a anonymous class implementation. For example, you can always transform into an anonymous class as well. However, you can see there is a big advantage going to the lambda expression because we can simply reduce the number of lines it requires to write the same logic. I'm really proud about you, my dear students. You have completely understood what are lambda expressions in Java language. Now that you are in a journey to become a Java expert, I want you to provide some additional knowledge going beyond the regular Java lambda expressions. I believe by this point you understand about what are functional interfaces. Java language also provides some of the built-in functional interfaces. The intention is you can represent any Java method as a lambda expression. So let's go ahead and explore these four main functional interfaces in Java. First, we have a functional interface called Predicate. Predicate is taking some sort of a input and always returns a Boolean value as the output of the function. You know, my dear students, you can write a lambda expression directly against a functional interface. The abstract method name inside the predicate is called test. So when we are calling the test, we will get the output of Boolean value. Now the second variety of a method that we can think about is a method that doesn't take any input but returns an output value. This nature is represented using the supplier functional interface. The third variety of a method that we can think about is a method that takes some input but doesn't return any output. We have the functional interface called consumer to represent these kinds of methods. Since the consumer does not return anything, we do not have a return value from the accept method. The final variety of methods that we can think about is a method that takes a one type of a input and returns a different type of a output. We have a built-in functional interface called function to represent this exact use case. So whenever you are developing Java programs, try to utilize these built-in functional interfaces. It will provide you a lot of flexibility compared to writing your own functional interface. Here is a quick summary about built-in functional interfaces in Java programming language. You have to remember these four main functional interfaces, and there are a variety of functional interfaces based on these four particular functional interfaces. So try to use them whenever you are programming, and whenever you are reading, you might encounter other developers might have already utilized these built-in functional interfaces. Alright, my dear students, since we came to the end of this video, I want to summarize what we learned in this video. We started off understanding about anonymous classes in Java. Then we looked into functional interfaces in Java language. You understand the anonymous class can either be a subclass from an existing class or it can be an interface implementation. Then we learned about lambda expressions and how the syntactical variation changes between anonymous class and a lambda expression. Then we also understood how the functional interfaces and lambda expressions are connected together or related together. Then we spend some time understanding about Java built-in functional interfaces. Remember, my dear students, whenever you are writing lambda expressions, try to write the lambda expression against an existing or inbuilt functional interface, because that will help the other developers simply utilize those existing functional interfaces and program against those functional interfaces. So, with this knowledge, I think you are in a very good state to understand about Java generics. Therefore, I cordially invite you to join with my next lesson where we are going to learn about Java generics.